So our last question is about frequency histograms. All right, let me remind you what we learned earlier. Earlier, we learned about bar graphs. Okay, this was earlier. This is not what we're talking about now. Bar graphs represented categorical data. What is categorical data? Categorical data was labels that are not numbers. Okay, that's what we learned before. This is what we're learning now, okay? Frequency histograms. They're going to use bars as well, which is why I connected it to bar graphs. But they're going to represent how often a data entry appears. So I want you to focus on this often, okay? This is going to use numbers. The x-axis contains quantitative data. Okay, let's look at this. Quantitative is numbers. Organized into groups. Oh, there's so many keywords here. Groups, bins, or classes. So I used all of these three words because you're gonna see this a lot in 1342. Groups, bins, or classes. And we'll go into that in a little bit. The y-axis measures the frequency, or how often the data appears, and the bars in a histogram must touch. All right, so let's look at our histogram. I hope you've noticed that this following graph is a histogram, and it represents the number of text sent. In fact, this is the same data as I had presented to you before. This is the x-axis, and it tells us that this is quantitative data. Quantitative. What does quantitative mean? This is numbers. I want you to think of quantitative as quantity, okay? And then we have the y-axis, and this represents frequency, which frequency means how often. Okay? How often do you do something? Like, how often do I go to the movies? Well, back in the day, it was a lot. Right now, it's not too many. But how often do you drive your car? How often do you go to class? How often do you do homework, right? So the frequency of things. And then here is the bins. Let's talk about the groups or bins. One of the cool things about histograms is that the data is grouped. So this bar, this whole entire bar, represents from 10 and then 2, this is really weird, 10 to 19, or any number slightly before 20. Okay, so this can have a 10, this can have 11, this can have 12, 13, 14, 15, 16, 17, 18, 19, maybe like 19.5, right? Anything 19-ish, but not 20. Where's the 20? The 20 is in the next bar. 20, 21, 22, 23, and so on, all the way down to, you guessed it, 29. So this is why we say a group of numbers, because there's a group of numbers in here. There's a group of numbers here, group, group, group. Got it? All right, another thing that's a difference, a big difference from a bar graph is that these graphs touch. Why do they touch? And that actually brings in that idea of this 20 belonging to this one, is because if they touch, it means it keeps going, so there's no break. So somewhere in there, that 20 has to belong to the next thing instead of the previous thing. I hope that makes sense. All right, so let's try to answer some questions. Oh, like always, let's focus on title. Let's focus on the axes. Let's see, and sentence. Let's move forward. All right. This is the only one we have, so I want you to really pay some close attention to this histogram. The frequency histogram shows the minimum daily temperature reported in El Paso, Texas for September of 2020. So this is the minimum daily temperature. Before I answer any questions, let's focus on the title, minimum daily temperature in El Paso. Title, axis, let's go in here, x-axis. What does x-axis show me? The x-axis shows me the minimum temperature. So if I look at this numbers, this is 50 degrees, 55, 60, 65, 70, 75, 80. And actually it's a continuous thing, so all the numbers in between. So anything between 50 to 55, 55 to 60, and so on and so on and so on, okay? So I know that these are temperatures. All right, now let's talk about, so the x-axis is temperature. Let's talk about y-axis. Y-axis, frequency. The number of days. How many days, right? How many days this temperature occurred? Is there a key? Not in this case, because it's a histogram, so this one doesn't have a key. But what we do have is the ability to make a sentence. Okay, so let's make a sentence. I'm going to pick a random graph. A random bar. Just go in anywhere and pick a bar. I'm going to pick this bar right here and I'm going to make a sentence about it. Let's do it. The number that I see here is, remember I follow it to the side, is going to be 1. I see that one day, and I know it's one day because look over here are days. One day in El Paso had a temperature from, all right, this is like that key part that you're learning. Maybe if you've never seen a histogram before. Remember that your bar is a bin. You cannot say 75 degrees because that's not true. This bar can have 75, 76, 77. So what I have to give you instead of is like a group of numbers from 75 degrees Fahrenheit to, and I'm going to say 79 degrees Fahrenheit, not 80, because that 80 belongs to the next bar, okay? Be very cautious in not saying 80. One day in El Paso had a temperature from 75 to 79 degrees Fahrenheit. Awesome. I feel ready to get my question started. So I'm going to kind of pick and choose, especially because there's only one question. So let's pick and choose which ones I'm going to answer with you, okay? How many days had a temperature between 55 to 59? How many days had 55 to 59? So I'm going to look in here, and I know that's this bar right here. This is 55 to 59. How many days? I think it's 3 days. Beautiful. I'm going to leave B to you because I think you can do it. Which class contains the most data? This is kind of similar to the bar graph. So I had given you a clue about the bar graph. How many days had a temperature of exactly 66 degrees Fahrenheit? Where would I find 66? 66 would be in here somewhere. But let me tell you this is why I picked to answer this question. I cannot tell you exactly how many days. Why not? Because there is 5 days in here. This bar contains 5 days. But I don't know what the temperature was. Because remember, this bin contains what? It contains 65, 66, all the way to 69. One of the things that happens when you put stuff in a histogram is you lose the original data. Let's write that down. Let me give you an example of like a real life situation. Let's say that I buy those bins at Walmart. You know, they always put them like after Christmas. And I put stuff in there and I don't label it. I just put stuff in there and I put it in my closet. And then every time I'm like, what's in that bin? I maybe know that it's like Christmas ornaments, but I don't know exactly what Christmas ornaments are in there, right? So it's this idea of putting something in there And once you put it in there, it's in there, but you don't know exactly what's in there unless you sat there and labeled it exactly. So let me tell you which graph labels things exactly. I hope you guessed it. A, stem and leaf plot. You see how things are labeled exactly, like 65, 66, 76, 78. So this one keeps its original data. This one does not. Okay, so what are we going to answer? Can't tell. Great. Ooh, D, a temperature of 70 would fall into which class? I know you can do this. I'm going to leave that up to you. What is the highest temperature? Oh, wait, let me actually emphasize class. I've been calling them bins. So this is bins. So correct answer for this would be something like saying, we would label this like the first bin, second, third, fourth, or you can also give it the name of the width, which would be like the bin that contains 55 to 59. So stuff like that. You can label it as first, second, third. You can label it as the class width. Part E. What is the highest temperature in September? What's the biggest temperature you see? This one's also a little bit tricky. I don't see an exact biggest temperature. The biggest temperature could be anywhere between 75 to 79 degrees. All right, identify interesting features in the plot. Look for big ideas rather than individual entries. You got this, you can answer this.